Hello everyone. So today we'll cover the topics which are GCD and LCM. Okay, so we'll cover these two topics and we'll solve some problems on this. Okay, these two topics are very important. Like when you'll advance to the hard problems which are related to number theory, maths, you'll see there are so many varieties of problems which are based on the concept of GCD and LCM. So what we'll do in this, first we'll know what is GCD, then relationship between GCD and LCM. Okay, GCD and LCM. After that, uh, we'll we'll find out a brute force way to calculate GCD. Then Euclidean algorithm to find out the GCD. Okay, and after that we'll solve the problems. Okay, so see, what we want to know is that we have, okay, whenever it comes to GCD and LCM, it's not come for only one number. Okay, like there's exists GCD and LCM for either two numbers or more than two numbers. Okay, so let's start with the only two numbers. Like we have 20 and 5. So what is GCD? GCD or HCF? Highest common factor, greatest common divisor. Okay, the meaning is same. So what we have to find? We have to find a number x. Okay, which is greatest. Okay, in the set. Okay, like x is belong to set and x is the greatest of all numbers which are in the set. Okay, this is set, and what this set represents, this set represents the divisors of a and b, both number. Okay, this is a and this is b. So here this is the set which is the divisors of a comma b, like a common divisors a and b have, and from that set, which is whoever is the biggest number, here it is x. Okay, it will be the GCD. So for 20 and 5, if we'll do prime factorization, it will be 2 into 2 into 5 and it will be 5. So we can see the GCD is 5. So GCD of 20 comma 5 will be 5. Now what is LCM? LCM is lowest common factor. Okay, so if I have number 20 and 5, so I have to find such x which belong to a set. Okay, we'll consider first it's some set, and x will be the lowest from the other numbers from that set. Okay, these are the other numbers from this set. Okay, now what this set is, okay, what does it mean? This means this set is the, it includes all numbers, okay, which can get divided by a and b both. Okay, here this is a, this is b. Okay, this set represents all the numbers which can get divided by both a and b. So in case of 20, okay, we have prime factorization like this, and for 5 it was just 5. So it's 5 into 2 into 2, so it is 20. Okay, this kind of calculations we already did in our high school, like when we wanted LCM, we used to get the common numbers only one time and then all other remaining numbers. Let take this. Okay, let's take 15. So what will be prime factorization? 2 into 2 into 5, and for 15 it will be 5 into 3. So we used to take 5 only one times, then 3, then 2. Okay, so it will be 2 to the 4, so it will be 60. Okay, so it will be the 60. So for LCM of 20 and 15, it was 60. Okay, we used to calculate like this. So here's a general formula for LCM and GCD. Okay, it's kind of relationship between, if I have number A and B, so GCD of A comma B into LCM of A comma B will always be A into B. Okay, this is the formula, and using this formula we find out GCD of a number, and if we want LCM we use this formula. What we do, LCM will be A into B by GCD. Okay, we always do this thing. Why we find out GCD and not LCM? Like why we why we can't do GCD of equal to A into B LCM and try to find LCM, not GCD? Okay, why? The question is why we prefer finding out GCD and from GCD we find out LCM. See, take a normal case. Okay, if I have number A and B, where A is less than B, and I have to find greatest common divisor. Okay, let's say greatest common divisor of A and B is X. Okay, so what does the property of GCD say? Okay, it says X must divide A and B both. Okay, so it's not possible X will be less than equal to B, or okay, it will not lie between A and B. Okay, so this case is not possible. Neither it will exceed the limit of B. Okay, which B is the greatest number. So what's the possibility of X? It's A. It will always less than or equal to A. So if I have to find GCD in a very normal way, like I'll go in a linear way, I'll check for all numbers. So I have to traverse from 1 to A only. Okay, so it's O of A time complexity. We'll consider like this. Okay, now when it comes to LCM, okay, now we'll take the case of LCM. So what LCM says? LCM is like lowest common multiple. So a number X, okay, which will get divided by both A and B. Okay, now here again X will not lie between A and B, because if it's between A and B, B will never divide it. Okay, another case, X can't be less. Okay, this case is false. This case is false, and this case will be false. Why? Because if X is less than A, okay, neither A will divide it, okay, and also B will not, also B will not divide this number X. Okay, so x will always lie in this case. Okay, P. Now if I have to find out, okay, the number x in a very brute force way, I'll travel from B to where? Okay, I really don't know. Probably I will travel from B to some a very large range. Okay, okay, like I really don't know what is upper bound here. Okay, it can be anything. So here I really don't know that how many steps I'll require. But in the case here, I already know that I have to start from 1 and the upper bound will be the A. But in the case of LCM, I really don't know. Like from even if I start from B, where I'll go. Okay, for how many numbers I have to check. Okay, so what's better idea here to calculate GCD, and with the help of GCD I can now calculate LCM. This is the easiest way. Now, what I have to do, let's see the easiest way to calculate GCD. So we already know we'll go from 1 to A if I have A and B. Okay, if we'll consider I. Okay, we are traversing over I. So it will be like, if we write like this, for I equal to 1, I is less than equal to A, I plus plus. And we already know that one will be the always GCD, okay? Because one divides everyone, okay? So our answer will be 1. And let's start from 2, okay? If A modulo I equal to 0 and B modulo I equal to 0, what we'll do, we'll update our answer. It will be like, answer will be the I. And whenever we'll find another I which will divide A and B both, we'll update it, okay, because we want greatest common divisor. If we find out another greater number than previous answer, we'll update our answer, okay. And other approach will be like, I'll start from A, I'll go till 2, and whenever I'll find the first number, I'll break from the loop, okay, because it will be the greatest number if I traverse from the backside, okay. But it is O of n, okay, and it's not efficient to calculate GCD, okay. When it comes to the numbers like which are nearly 10 raised to 8, 10 raised to 9, okay, we can't get GCD of these numbers, even 10 raised to 16 or 18, okay. For these kind of numbers we can't use this approach, okay. So here comes another algorithm, okay, which is very important. See, it is Euclidean algorithm, okay, and it's very fascinating. See, let me create two numbers here. Let's generate them. Mm, like 2 into 3 into 5, 2 into 3 into 7. What will be this? It will be 30, and it will be 42. Okay, I have two numbers. See, I'll I'll tell you like how Euclidean algorithm works. Okay, see, what two numbers I had? 30 and 42. Let me rub. I have 30 and 42. And what I have to find? I have to find GCD. So what Euclidean algorithm does? It tries to convert this thing into a sub-problem, a kind of sub-problem. See, like this. consider I have some block. Okay, this is a block which is of length 42. Okay, okay, if I have number which divides 30 and 42. Okay, I have what's my goal here? I have to find number x, okay, which is greater in that set, and it divides like 30 modulo x equal to 0 and 42 modulo x equal to 0. Okay, so what Euclidean algorithm says, let's consider I am partitioning it into this way. I have 30 and what's remained here 12. So what I know that, okay, hypothetically I am considering I have such x. Okay, I have some x. That x will divide this 30, okay, and also 42. Okay, if it divides 30, so whatever remaining part, what is, it's 12. Okay, so that number should also divide this remaining part. Okay, so see, I'll repeat this thing. Okay, I have a biggest block of 42. Okay, and what I'm saying, I have such a number x, okay, which divides 30 and also 42. So what I'm saying, I'll cut out that 30 part. Okay, and I'm considering I have such x which divides this 30 size block. Okay, so if I have such x which divides 30 and 42, so it means that if I am dividing that 30, okay, after dividing that 30, if I'll remove those 30 parts. Okay, these are cut down. I This is x, this is x, this is x, this is x, this is x. Okay, these all are x. If I remove those x, okay, out of 42, okay, 12 will remain. Okay, a block of 12 will remain, because what I'm considering, I have such x which divides 30 and 42 both. Okay, so first I considered that I'll remove those 30 size block from it using some x. Okay, after removing that 30, I'm remained with 12. Okay, now I have just 12. Now I'm considering that I have such x which divides this 12 also. Okay, of course it has to divide that 12. If it divides that 12, then only it can divide 42 and 30. Okay, now what's my sub problem is? Now my sub problem is I have to find such x which will divide this 12 and 30. Why 30? Because here I considered I have converted this 42 into 30 and 12. Okay, I considered that I have such x which will divide this 30. So that x must divide 12 also. Now I have this sub problem. Now I am considering that x divides 12. Okay, now that x divides 12 in equal parts. Okay, so if I'll take block of 30. Okay, now here at this stage, what is my sub problem? It is that I have to find x, okay, which will divide, okay, which will divide 30 and 12 both. Okay, now if I have a big block of 30 and I'll convert this 30 block into two 12 blocks, and what will remain? 12 and 24, it will the remaining part will be the 6. So now what I'm considering, same the way we consider things in this part. Okay, we are going to repeat it here. So Here I have some x which will divide 12. Okay, if it will divide this part of 12, it will also divide in the same way for this 12. Okay, x, x, x. Now I have to find such x which will divide 6 and 12 only. 12 comma 6. Okay, now you can see if I'll create, okay, I hope you did understand this part. Okay, at this stage, okay, I'll repeat. At this stage, what happened? We had 42. We divided it in 30 comma 12, where we considered that I have to find GCD in 30 and 42. If I can partition 30 with help of x and also 42, then if I'll partition that, like if I'll cut out that 30 length block with help of x, so out of 42, 12 will remain. So this condition is must. Okay, what is that condition? The condition is that remain part of the 12 size should also uh, get divided by that x. Okay, we can completely cut that 12 size block with the help of x. Okay, now now what was my sub problem at this stage? Now I have to find such x which will divide that 30 and 12. Okay, for 30 and 12, what we did, 30 can be filled up by two blocks of 12 and remaining portion of size 6. So now what my sub problem? My sub problem is, now I have block of 12 and 6. Okay, I have to find such x which will divide 12 and 6 both. So if now I'll draw, I have block of size 12, and if I'll divide it with 6, okay, it got equally distributed, and there is no remaining portion here, like in above cases. Okay, here 12 was remainder. Okay, here 6 was remainder, and in this case there is no remainder. So from this what we can say, we can divide 12 and 6 using 6 block. Okay, now from this we'll go to the this stage. What was it? 30 comma 12. Does 6 divides 30? Yes. 12? Yes. Now we'll go to the this part. 42 and 30. For 42, does modulo get taking modulo with 6 is 0? Yes. 6 sevens are 42. 6 fives are 30. Okay. Now with this algorithm, what did we find out? That 6 is the GCD of 42 and 30. So what we did here, we had some bigger block. We Okay, bigger block, like whenever I'll get a number a comma b, one will be the smaller and one will be the bigger. Of course, if a equal to b, the answer will be the a or b. Okay, like these are the same numbers. So greatest common divisor will be the a in this case. But in all other case, there will be the someone which is bigger and someone smaller. So what I'll do, I'll equally partition I'll make equal partition with that small number. Here we consider a, and some b minus xa will remain. Okay, where I'll say na, where here n is 2. Like I divided a with two parts. Okay, now my problem will be, I have b minus na block and a block, where of course b minus na will be smaller because it's remainder after dividing by a. So it will be the always less than A. So we'll solve for this. Now what we'll do, we'll make B minus NA size block in here, then something will remain. And after doing this recursively, at last when we'll find out a such box, okay, which exactly will get filled in this bigger box, it will be the GCD. So when it comes to the code, it's your homework. Okay, how can you implement Euclidean's algorithm? Okay, you can go to the CP algorithm site. Okay, and you can read the blog. Okay, now I have GCD, so LCM will be A into B by GCD. Simple. Now what we'll do, we'll solve some problems. Okay, we'll solve these two problems. Okay, so this is less rated. Okay, we'll solve this first. So the question is, let LCM of x comma y be the minimum positive integer that is divisible by both x and y. Okay, here's the definition of LCM. Okay, so we have given two integers L and R. Find two integers x and y such that x and y both lies between the range of L comma R, and the LCM of x and y also lies between L comma R. Okay, so what we'll do first, we'll try to figure out this thing with some examples. Okay, see, I have given L comma R range, and I have to find x comma y, okay, which are in the range of L comma R, such that LCM of x comma y will also be in the range of L comma R. And when you'll read this question carefully, if it's impossible to find such integer x and y, you have to print -1. Otherwise, print the value of x and y. And here's the catch. Okay, if there are multiple valid answers, you may print any of them. So whenever a question comes like this, if there are multiple valid answers, so there's always a pattern or something you can find out very quickly. Okay, uh, when it comes to multiple valid answers, there's always a pattern. Okay, you have to try some multiple test cases and you can find that pattern. So we have to look this thing. Okay, we have to find this pattern in this question. So see, what, take number any x, okay, and some y. So what will be the best case, okay, so that will not exceed y, like how I should put this. Okay, I'm considering that x and y are in the range of L comma R, okay, inclusive range. Now I want LCM also be in this range. Okay, if I want these both cases, this case and this case, if I'll think greedily, so what I really want, that somehow, is it possible somehow that LCM of x comma y will be maximum of x comma y. If it is maximum of x comma y, and we already know that both x and y are between L comma R range, okay, then if this is the case, this is the valid case, okay. So we have to find, does something like this will exist, okay. So if I have some number x, now I have to find some LCM which will, okay, here in this case I'm considering x is less than y, okay. If I have some number x and with some number y, LCM should be, okay, we have considered that LCM will be the y, okay. If I'm considering y is the greatest, so LCM will be y here, okay. So I have to find such number, okay, which will lead to me y, okay. Like I really don't know, like I have complete range, na, I have complete range of L comma R. I really don't know where will be the x and y will lie. I can just, I really can't just travel from L to R to find this thing, okay. So now what's the possible, what's the smallest number here, okay. What will be the smallest y we can find, okay. If we have to find a number which will less than r, okay, the best thing what we can think with that x, we have to find smallest y, okay. We have to find smallest such y, okay. So can you think like this, if I have x and 2x, what will the LCM? 2x. If I have x and 3x, it will be the 3x. But what we really want, a number which is less than equal to r. So we have to check this case, okay. We have to check just this case, that our x and 2x both must lie between this range, okay. If I have number x and 2x, LCM will be the always will be the 2x, okay. And if 2x here is lie between L and R, then our problem is solved. But 2x exceeds the range, then it's impossible. So now we found the relation between x and y is like, the answer will be x and 2x. But what will be the x? So if you'll look here carefully, it will be always good to take x as L, because L will be the smallest number in that range. So 2x will be 2L, and if 2L is less than equal to R, then we have answer. We'll print L and 2L, and in other case we'll print -1. So let's try to code this. Okay, I have number till 10 raised to 9. Okay, I can use int here. I have int L comma R. Now what I said, that if 2 into L is greater than R, cout -1 -1, and else cout L and 2 into L. See, for 1 and 337, 1 and 2, as they said, multiple valid answer exists. So even here the output is 6 and 7, 1 and 2 also right. Okay, there's no issue with it. In 13 to 69, 13 and 26. For 2 and 4, 2 and 4. But for 88 and 89, there's no answer exists. Let's submit it. Okay, now the next question. Okay, in this next question, you'll learn a new thing. Okay, like when I was covering the theory, I just took the two numbers only. Okay, while I was calculating the GCD. When it comes to the multiple numbers, okay, so GCD of 0 and any number is A. Okay, because 0 by any number n. Okay, like we can divide 0 by any number n. Hmm? And A by some number n. So it will be the always good to take n as A, because n can be A here. Okay, let here consider a small n. Okay, we really don't know. And n is n belong to the set of all integer, no, natural numbers. We can't take 0. So in this set, we'll have all numbers from 1, 2, 3, somewhere will A come, then A plus 1, and such that n. Okay, now I have to find another n number which will divide A. And we'll look here, A already exists in that set. So why not to take A? So GCD of 0 comma A is always A. Any number ha have GCD with 0, the number itself. Okay. Now when it comes to the multiple numbers, what we can do, we'll first assign GD equal to 0. Consider we have GCD calculated in GD, and for all that range 1 to n, GD will be GCD of GD comma whatever number is in that array. Okay, in this manner we take GCD of multiple numbers, like we have number like 20, 10 and 5. So first we'll take GCD of 10 and 20, it will be the 10, then 10 and 15, it will be the 5. So GCD for all these three numbers will be the 5. So in this question we are going to solve the problem in this manner. Okay, let's see what's the question is. So the question is, we have an array A consisting of n numbers a1 a2 to an. Okay, friends ask you to make the GCD of all numbers in array equal to 1. Okay, in one operation you can do the following: select an arbitrary index, okay, arbitrary index, and make that number equal to GCD of that number and the index. Okay, now the number will get update. Okay, it will be the GCD of that number and the index of that number, and the cost of such operation will be the n minus I plus 1. So if I'll update first number, the cost will be the n. If I'll update second number, it will be the, okay, here first number the cost will be the 6, second number the cost will be 5, 4, 3, 2, and for the last it will be the 1. Okay, so from this what we can say, it will be better it will be better if I'll try to find numbers from this end, from backside. So it will cost me less, because the what question says the minimum total cost of operation. Okay, see, now what I have here, I'll introduce a new concept. Okay, coprime. What coprime says, A and B are coprime if their GCD is 1. Okay, it's not necessary. Okay, it's not necessary that A and B will be prime. Okay, take case like this, 8 and 9. Both numbers are not prime, but they are coprime because their GCD is 1. So it's universal. Okay, it's universal thing that A and A plus 1 will always be a coprime. Any consecutive numbers will be coprime. Okay, see, what question says, we have numbers. See, let's take the test case where the answer is 3. Okay, this is the case. Okay, it's not getting copy. See, what the test case was, 150. I think there was 90, 180, 120, 60 and 30. Okay, if you look carefully, the GCD of whole array will be 30. Okay, and the index will be 1, 2, 3, 4, 5, 6. See, if I update this number, it will be the GCD of 30, 6, which is 5. Now, if I'll do operation on this, like I'll updated, I'll update this 30 with 5, and now again I'll check for GCD. Now the GCD is 5. You can see GCD is 5. It's not equal to 0. Now again, instead of this, like, I'll try this. Okay, now I'm considering that I have retained my 30. I never did operation on last index. So GCD of 5 and 60, it is also 5. Okay, so the for whole new array, it will be the again 5. But if I have this 5, okay, and now I do this, okay, 6 by 5. Okay, what was I doing? Okay, I have 150, 90, 180, 120, 65 by 5, GCD is 5. Hmm? Then GCD of 30, 6, it's 5. Okay, sorry, GCD of 30, 6 will be 6. Okay, in the last case, GCD was 6 when I was updating this, and when I was updating this, the GCD was 5. Okay, in this case it was 6. Okay, now when I updated both, okay, these both, you can see now the GCD is 1. Okay, so uh, can I say that we need to update only two indexes? Okay, you can pause the video here and you can try to think why I have to update only two indexes. Okay, like why two indices only? What I can say is those two indices will always be the consecutive. Okay, try to think with this coprime and why I told you that how we take GCD of multiple numbers. Okay, try to think with this. Now I'll continue. See, here GCD is GCD of, I'll say just GD. GD is GCD of A1, A2, A3, A4, A5, A6. Okay, so now what I did, when I took two new numbers, the set become like this: A1, comma A2, comma A3, comma A4, comma A5, comma A6, and 5 and 6. Because I took GCD of A5 and 5 and replace A5 with it, and A6 with 6 and then replace with it. Okay, so we have these numbers in set now. Now what I told earlier, that any consecutive numbers are coprime, which means that GCD of 5 and 6 will be 1. So GCD of 1 and A6 will be 1. With A5 it will again 1, and so on. So here GCD will be 1. So this was the only thing. So for the question, what we have to do, consider we have GD where it is GCD of all numbers A1 to AN. If already GD is 1, we need 0 operations. If GD, okay, GCD of GD, comma, GCD of last number and its index n, if this is 1, answer is 1. Another case, if GCD of GD, comma, GCD of second last number and n minus 1, if this is equal to 1, then it will be the 2, and in other case we have to just print 3, because 0 is the smallest operation we can have, then 1, then 2, and we already know that if I'll update last two, cost will be the 1, 2, and adding them up will be the 3. Okay, even if the case where doing operation on the third index, like third last index, even if it's feasible, doing this way is also feasible, because the cost of operation will be the 3 in this case also. So we have to check just two indices only. Okay, so how can we code? See, the range is 10 raised to 9, so I can take int here. So int first GD equal to 0, int n, scene n, Okay, this is inbuilt GCD. Okay, in C++ we have inbuilt GCD which calculates GCD between two numbers. GD comma vi. Now we have GCD. Okay, if the GD equal to 1, cout 0. Another case was else if GCD of GD comma GCD of uh, v of n minus 1 comma n. Okay, here we are considering one base indexing. Okay, like whenever I am using that I, okay, here I is one base indexing because you can see it's from 1 to n. Even my actual numbers are on zero base indexing. Whenever I am taking I have to consider one base indexing. If this is case, cout 1, else if same thing, just it will be n minus 2 and n minus 1, cout 2 and else cout 3. Done. And just print a new line here. 1 0. Okay, why 1 is here? It should be 3. Are we getting wrong somewhere? Okay, we have to check with 1 equal to 1. Now it's 3, then again 3, then 1, then 2, 2, 1 and 0. Okay, let's submit this. So this was the right answer. I hope you understood the concepts I have taken in this lecture. We covered the main topic. The main topic was actually how Euclidean algorithm works. Okay, like so many people are out there in YouTube, like they don't talk about how it works. Okay, now I talked very less about Coprime. Okay, you can explore these things by on your own. Okay, and another thing was the homework. The homework was you'll see how you can write the code for Euclidean algorithm. Uh, for starting, like for the easy questions, you can really use this. Okay, this inbuilt function. There is no need to implement your own Euclidean algorithm there, but it's good practice to know. You must know how to code that Euclidean. So that's it for today. I'll put the link for questions, like those two problems I have taken in description, and again CP algorithm blog on Euclidean algorithm. That's for it today. Thank you.